Okay, this is the units of chapter 1. Okay, standard of length, mass, and time, LMT system with the dimensional analysis. Okay, so this is the five basic quantities, right? So what is it? Length, mass, time. Okay, length, mass, times temperature and current. Okay, so basically temperature and current, we will see these quantities later on. Okay, during when we learn about in the chapter of thermal physics. Okay, and current, basically we will use these basic quantities is in the semester 2. Okay, where we want to learn about electricity. Okay, so this is the five derived quantities where we can have you obviously have already seen this one: velocity, accelerations, force, momentum, energy. Any quantities that is not a base quantity is called the derived quantity. So remember, just use that word, meaning that if you tend to be, let's say, what is momentum? Momentum is not a base quantity, therefore it is a derived quantity. Simple. Okay, right. So this is all the approximate values, and remember about the prefix. Okay, you can learn how to memorize all these prefixes, especially to the 10 power of negative 12 here and 10 power of 12 here. Okay, that's but please remember to know at least one or two names that actually doesn't sound familiar to you, right? Okay, so this should be the dimensional analysis where we stopped last time, right? So please, I will recap it again. The quantity, okay, is based on the dimensional analysis is what we want to do some analysis in terms of a physical formula. Okay, a physical formula, or we want to know first of all what is about the dimensional analysis. We want to do some analysis to the formula. Okay, formula, meaning that the equations, right? And also we want to make sure that what is the SI units, okay, SI unit for the parameters or for the dimensions. All right, so this is the examples of the dimensions that we use in the physics. So basically we have a distance. Distance is also the same as length. Okay, displacement, in terms of how you want to use the terms. Okay, the terms in terms of physics are different, but in terms of dimensional analysis, meaning that we calculate or we measure length or we measure displacement using we can measure using from one point to another point, meaning that we can get we can use meter ruler, for example, meter ruler, or we can use I don't know, maybe you can use any kind of measuring tapes that can measure between point A to point B. Therefore, the dimension is length. Okay, so any kind of quantity that related to length can be, you can use L. And how about area? Area is obviously a derived quantities. Okay, how to get area is basically width times length, or width times length, for sure. Panjang kali lebar. Okay, although in Malay is panjang kali lebar, but in physics, the dimensional, when we want to use a dimensional, all values will become length. Length times length. Okay, remember, if this is the area, so length times length. So length is L, and this one is also L. So L times L, we get L squared. Okay, so that's with the volume, L cube. And remember, velocity is length over time. What is length? L. What is time? T. So T is capital, T capital. L over T. Okay, L over T. And the acceleration is L over T squared. Okay, why? Because that's why when we acknowledge the SI unit, so this one, the SI unit for the velocity will become meter over second, because in length, the SI unit for length is meter. Okay, and the SI unit for the time is second. Okay, and how about this? L is meter, and how about T? S square. Okay, how about energy? So let's say energy is M is kg, L square is what? Meter square over S square. This is how the simple physics can be when it comes to, you don't have to memorize all the SI unit. Okay, in fact, you can do a dimensional analysis in order to get the SI unit. Okay, look at what is the purpose of the dimensional analysis. Okay, right? So for example, okay, the questions ask you, show that the expression, this one can be, if you look at the examples, this kind of example is actually inside your survey textbook. All right, so show that the expressions of v equals to v naught plus at, v equals to v naught plus at, for example. Okay, v equals to v naught plus at, okay, is at a dimensionally correct. Okay, show that is a dimensionally correct, meaning that you need to prove that this equation is correct. Okay, you don't have to measure whether it is correct or not, because it is already correct. Okay, the questions have already tell you that the equation is correct. Okay, you just need to prove it. Okay, how to do some proof? How to prove you're dimensionally correct? So you need to do some dimensional analysis. How do they? Okay, this is v equals to v naught plus at. Okay, so you need to do all, you need to put all dimensions for each parameter. So for example, the parameter of v is L over T. L over T. Okay, sorry. Okay, L over T. And how about V naught? V naught is the initial velocity. V is the final velocity. Although V naught is the initial velocity, it is also L over T. Okay, L over T equals to L over T. All right, and another one is AT. Okay, AT. How about AA is acceleration? Acceleration is L over T square. How do I know that the A is L? This is based on my experience. I already know that A is the acceleration, therefore I know L over T square. Okay, as you used to have the same, you do it again and again and again, you will tend to memorize all the dimensional analysis. So how about T? T is T lah. Okay, so you can cancel out T and this T at the bottom. So therefore, L over T, L over T. Okay, it will be like L over T on the left side is equivalent to this one. Okay, L over T plus with L over T. Okay, so the terms in the left side, okay, the terms in the left side can be equal to, it must be equal, because the expression is dimensionally correct. The term on the left side must equal, okay, must equal to the term on the right side. Okay, let's say the first parameter is V naught. This one is V naught. This one is AT. Okay, this is one place. This is another place. So one place is L over T, yes, correct. And another place here is also L over T. Okay, so meaning that if the expression or the equation is dimensionally correct, you should prove it that every places, okay, on the right side must be equal to the left side. If one of the place, meaning one of the parameter, for example, is this place, okay, when you do the dimension, then it becomes L over T square. Okay, does it equal to the on the left side? Tak sama.
No.
Yeah, so therefore it is the expression becomes dimensionally incorrect. Okay, so salah. So you need to prove that on the left side is equal to every point, every places on the right side. Simple. Okay, every places. So nanti bila buat, kalau ada satu place dia L over T, satu place lagi L over T square. Salah lah. Okay, this expression is dimensionally correct. But for the purpose of this question, they want to know about show that the expression. So, tunjukkan. Bila tunjukkan, kena soalan proving. Belah kiri sama dengan belah kanan. Simple. Okay, tapi tak perlulah nak kena, oh ni ada L over T. Lepas tu yang ni L over T. Kita perlu tambah ke? No. Biar je. Kita just tulis, it is dimensionally, it is show that this is dimensionally correct. Simple. Tak perlu pun nak buat L campur T plus L over T plus L over T. No, you don't need to add it. Okay. So, this one. For example, I'll show you that this equation first. Okay. This is X equals to X naught plus Vt. Okay, X in your case is the displacement, okay, where V is the velocity and T is time, right? So what is X? X is length or displacement, doesn't matter. So it is a L. L equals to L under this one. Okay, this one is L. And V, how about V? V is L over T times T. So you cancel out T. There you can get on the left side is equal to every places on the right side. Okay, let's, I jump to this question. Okay, for example, V equals to V naught plus half AT squared. How about if you have a half here? Okay, then half here it is a coefficient. Okay, coefficient. So coefficient doesn't include, you don't have to put all the coefficients inside the dimensional analysis, just the parameter, just the terms we use. Okay, so this is L over T. So definitely every places on the right side must equal to the left side, which is here L over T, and V naught is also L over T. Definitely, and half doesn't put, they have to put. And how about L over T acceleration is L over T square, and time is T square. Okay, T square. So another T square here, then you can cancel out. One moment. Okay, 1 over L over T square. Okay, so you can cancel out T square and T square. So therefore, you can see L over T is equal to L over T plus L. Okay, so this is where this is a wrong dimensional analysis. Okay, so this is not dimensionally consistent. This is not consistent in terms of dimension. Okay, so this is how the examples of dimensionally inconsistent. All right. Okay. Okay. Okay, so this is the uncertainty in measurement and significant figures. Okay. So accuracy of the measurement is limited. So in here we want to know about the significant figures. Okay, and also the measurements. All right, okay, this is the rules. Okay, the non-zero digits are, I hope that everybody have watched the videos. All non-zero digits are considered significant. Non-zero, okay, this is all significant. This is 5 significant figures. Okay, remember we will use significant figures. Okay, because inside the question, if the question asks you about the please write your answer. This is the kind of question where you want to apply the significant figures. Okay, write your final answer in 3 significant figures. If you write down the correct answer but in 4 significant figures, then you will get at least minus one mark at the final answers. Okay, because you didn't follow the instruction to write down or to write down your answer to 3 significant figures. Okay, so that is how the importance of the significant figures will be. Okay, Right, so this is the 5 significant figures. Every points, okay, regardless of a non-decimal point, this is non-decimal, and this is a decimal point where you can have a point. Ada nombor perpuluhan dekat situ. Bila ada nombor perpuluhan dekat situ, okay, when you have a decimal point, so you can have 123.45, 123.45. So you will have 5 significant figures, and this one has 2 significant figures. Okay, this one is 5 significant figures. Okay, all right. So let's go. Zeros appearing anywhere between 2 non-zero digits are significant. Okay, I hope that everybody should understand the zeros inside the non-zero digits, okay, or inside the figures, that in between there is a non-zero digit, so definitely it's counted as significant. And how about leading zeros? Okay, this is important. Leading zeros are not significant. Okay, leading zeros are not significant. For example, this is a decimal point where you can have 0.00052 significant figures. Okay, so what is the significant figures? Just two significant figures only. Okay, we doesn't include all the zeros at the beginning. Obviously there is no possibility to write down as, for example, 91,0000 without decimal. I don't think I can see this kind of value, but if they're involved in the decimal point, for example, okay, so this should be the 2 significant figures. Okay, because all the leading zeros, okay, are not significant. Okay, how about the trailing zeros? Okay, the trailing zeros, the next one. Trailing zeros in a number containing a decimal point are significant. Remember, the trailing zeros is significant or are significant. Okay, for example, 12.2300, we consider this as 1, 2, 3, 4, 5, 6 significant figures. But the leading zeros, 1, 2, 3, 4, doesn't include. But we can, the decimal point, in the decimal point, that includes zeros after the significant figure. For example, 1, 2, 3, 4, 5, 6 has 6 significant figures, and 120.00 has 5 significant figures. Okay, 120, for example, here 1, 2, 3, 4, 5. Okay, the decimal point has 5 significant figures. Okay, the significance of trailing zeros in a number not containing a decimal point can be ambiguous. Okay, ambiguous. Right. So what is ambiguous here? Remember. Okay, 122,300, for example. 122,300, 122. Okay, 300 has 6 significant figures in terms of what? Here, the non-zero digits, like this one. Okay, can be write down as 6 significant figures or 4 significant figures. How we do it? 4. Okay, we can write down this one, okay, in terms of scientific notation. For example, 1, 2, 3, 3. So it becomes 1, 2, 1.22. 1, 2, 3, 4, 5. Okay, 1.223. 1.223 times 10 power of 1, 2, 3, 4, 5, 6. Okay, 2, 3, 4, 5. Okay, times power of 5. Okay, so this is can be write down as 4 significant figures instead of 6. If 6, then 6. All right. Okay, so this is the examples. Okay, but okay, I don't want to here yet. Okay, I don't want to explain yet in terms of calculations. Okay, but I want to see. Okay, then you can go to the examples of the one that can be used wherever we use the significant figures. Okay, for example, this question. Okay, apply the several carpet installers make measurement for carpet. So carpet in the different rooms of restaurant. Okay, so this is the dimensions of room. Okay, the banquet hall, you have 14.71 as length and width 7.46. So basically the area for the banquet hall should be 14.71 times 7.46. You will get 109.74. Okay, during our classes, please, okay, take your calculator along. Okay, make sure you have your calculator in front of you, and then you can use that calculator to calculate whatever I'm showing here. Because when you do some calculator, when you punch in your calculator, okay, you will tend to get more, at least, okay, uh, remember, okay, you can easily get the idea of calculating, because that is very important. Okay, at least you'll be more confident in terms of settling the questions, right? So 14.71, 7.46, you will get 109.74. Okay, in your calculator, 109.74. Okay, in terms of significance, there are no, if you look at the question, there are no mentioning about write down in terms of significant figures. So how can this question becomes, how can this value, the final answer should, okay, from 109.74 becomes like this. Okay, 1.1 times 10 power of 2 meter cube, meter square. Okay, so basically 14.71, if you look carefully, have 4 significant figures, SF. Okay, however, the width is 7.46. It is a 3 significant figures. So during the calculations, we should get, okay, the final answer should follow the least significant figures inside the question. If the question asks you about area means that length times width. So in this case, for length times width, so the least significant figures for the area, it should be 3, because width is only 3 significant figures, while the length is 4 significant figures. So the final answer should follow. Okay, remember, the final answer should follow the least significant figures. If the questions involve, okay, in mathematics operation, we have plus, we have minus, we have times, and we have divide. Okay, if the questions involving multiplications or divisions, then it should follow the significant figures, the least significant figures. Okay, okay, so you should follow the least significant figures wherever it involves the multiplication operations, in terms of multiplications and divisions. Okay, so that's why if you look at the final answer, the answer is 1.10. Okay, obviously, we can write down as 1.1 times 10 power of 2. There is no wrong in terms of the final answer, but it is advisable for you to write down in terms of significant figures. Basically, where when we can look at the question 14.714, okay, 7.463, so we follow 3. Okay, we will follow 3 significant figures, the least significant figures from the questions. So that's why the answer, final answer, should write down as 1.10. Okay, and this one, this person, okay, answer it in the scientific notation, where you obviously use 10 power of 2, because the final answer you can write down, another final answer you can write down as 110 meter square. That is the simplest one, 110 meter square, because this is also a 3 significant figures. Okay, so that is for the rest of the questions. Okay, so solve below's problem. Okay, in terms of, okay, like I'm saying, in terms of multiplications and divisions, this one will follow significant figures. All right, so in here we have another types of problems. Okay, 6.74, 5.1 seconds. So what is the final answers? Okay, 12.7 pound plus 7.25 pound. What is the final answer? Okay, this one, this operation involve addition. Okay, so remember the number of decimal places after addition or subtraction is equal to the smallest number of decimal places in any of the individual terms. Okay, for the purpose of this question, okay, it involves addition and subtraction involve will involve the operation of addition and subtraction. We will follow smallest, this one, least significant figures, least paling sikit, least significant figures, and this one we will follow smallest number of decimal places, smallest number of decimal places. So in this case, the smallest number of decimal places is 5.1. So we should follow 5.1. And this one is 12.7, the smallest number of decimal places. Okay. All right. So this is the scientific notation. I believe all of you have already have no problem in terms of scientific notation or how to convert it from the leading zeros or trailing zeros numbers, or maybe a non-zero digits numbers. Okay, so you have no problem in terms of to convert between. So just make sure that you know the concepts of significant figures whenever you do the scientific notations. Okay. All right, so this is the kind of round off error. Okay, the last digit and calculated number may vary depending on how it is calculated due to rounding off significant digits. Okay, this one, remember, involving multiplication and divisions. Okay, so it should follow the least significant figures. All right, so this is another one, the conversions of units. Okay, conversions of units. Before that, any questions? Any questions?
Sir,
Yep.
for the addition and subtraction,
Mm-hmm.
does it follow the least significant figure?
Yep.
So like 15.1 plus 2. So we must follow the two significant figure. I mean, which is only one.
Yep.
Alright. Okay, understood. Thank you, sir.
Correct. Fine. All right. So, okay. You also asked me about L square equals to L square. Should we let it be or simplify as L equals to L? The answer is let it be. Just let all the questions, just let everything on the left side equals to the right side. Simple.
Alright, thank you, sir.
Okay. Okay, so should we continue? We have another half an hour. We have 20 minutes to go. Okay, so let me share the slide first. Okay, can you see the slide?
Yes, sir. Yes, sir.
Okay, very well. Thank you. Okay, so this is the conversions of units. Okay, conversions of units. Okay, I believe all of you have already mastering about the conversions of unit. But in terms of people, okay, maybe there are some students still having a problems how to convert from one units to another units. Maybe it is not emphasized in the SPM level, but in here we do a lot of conversions. We must be able to do a lot of conversions. Maybe a very complicated one is also you must mastering all of it of that. Okay, so the how to convert from one value to one value, you must consider the conversions. So we do a lot of cancelling out and in and out, okay, in order to do some conversions. Okay, for example, converting 26.4 meters, okay, 26.4 meters here, sorry, okay, 26.4, right, meter to feet. Okay, so remember 1 meter is equivalent to 3.28 feet, and 3.28 feet equivalent to 1 meters. Therefore, 26.4 cancel out with 1 meters, and then you can times this down. Okay, because I think all of you have your own way to solve the problems of converting units. But please, okay, you must be able to do this like from time to time. Please practice it. Okay, practice on your own. Okay, how to do the unit conversions. Okay, for example, if a car is traveling at a speed of 28 meter per second, Okay, is the driver exceeding the speed limit of 55 miles per hour? So this is the kind where you want to do some conversions in terms of 28 meter per second to miles per hour. Okay, you want to do some conversions in terms of meter per second to miles per hour. Okay, for example here. Okay, now we have 28 meter per second. One moment. Okay, 28 meter per second, right? So when you want to do some cancellation, okay, so 28 meter per second, so every time you see the units, okay, 28, for example, 28 meter, then point per second, you must put it at the bottom part, okay, meter per second, 28 meter per second. So put it at the bottom, and you must remember meter per second, convert it to what? Okay, meter to miles, obviously to miles, because that is the obvious conversions, and second to hour. Okay, so you must convert from meter to miles, okay, and second to hour. Okay, so first of all, okay, like they did here, is 28 meter per second, 28 meter per second. Do a lot of cancellations here. So 1 miles is equivalent to 160 meters. Okay, 160 meter, 1,609 meters. So meter and meter can be cancelled out. And how about here? Here is the seconds. But actually, you can follow through this one. Like for example, 28 meter per second. Okay, 1 miles over 1,609 meters. Okay, times width. Okay, remember the second is at the bottom of the equation. So you can put 1 second equals to how many hours, but the easiest one is 3,600 second equivalent to 1 hour. How do I know? Okay, this is from my understanding in terms of 1 hour equals to 60 minutes and 1 minute equals to 60 seconds. So 60 times 60 you get 3,600. So this one you need to do on the side calculations. Okay, so every time you see this one, then you can cancel out meter and meter, seconds. Okay, the concepts of cancelling is you must cancel from top to bottom. Top to bottom you can cancel out. Side to side tak boleh cancel. Okay, tepi dengan tepi tak boleh, tapi atas dengan bawah boleh di-cancelkan. Contoh, second dekat bawah dengan dekat atas. Yes, you can cancel out. Right? And then in the end, apa yang tinggal ialah 28 times 1 mile. 28 times miles times with 1 miles times with 3,600. Okay, divide with 1 hour. Okay, so that is how you did the times, forgot here, 1,609. Okay, 1,609 from this one. Okay, so in the end, the final answer should be 62.6 mile per hour. Okay, every time you do the calculations, then you get the final answer. That's it. Okay, but the true question is the driver exceeding the speed limit? That is the real question. Sometimes the students always just calculate the final answer, but they didn't know what is the purpose of the question. The purpose of the question is they ask about the driver's speed. Okay, is it exceeding the speed limit? Itu yang kena jawab dulu. So the answer is yes. By how much? Then you calculate. Okay. Sometimes yes is just put yes dah dapat dah markah. But people always kira, lepas tu lupa. That is all the mistakes from the students. Selalu jadi macam tu. Okay. So that's how. Okay. It's very you must be very careful with the questions. Okay. Then you can do on your own. Okay. This one is a bit tricky, but it kind of involve the square. Okay. Please do some revision in terms of that. But I can assure, let's say for example, 14 meter per second square. Okay, 14 meter per second square. Like, okay, just look at how do I do the questions, and then you want to convert it to kilometers. So times with, all right, times with. So 1 meter and 1 kilometer. Okay, so 1 kilometer I use it. 1 kilometer equals to 1,000 meters. Okay, times with. Okay, so meter dah gone. Tinggal second square. Kalau yang ada square, ada cube, ada yang power ni, first of all, what I'm doing now is I just put it at the outside square. Saya letak dekat bahagian luar square tu. So square dekat bahagian bawah, S square, okay, is equivalent to I want to change to hour. So 1 hour equals to 3,600 second. Yang square tu duduk kat luar. Jangan pedulikan dia. Letakkan dia di bahagian luar sahaja. Okey, letakkan dia di bahagian luar. Okey. Alright. So yang bahagian luar tu biar je. So jawapan dia nanti akan jadi 14 times with 1 kilometer times with 3,000. But remember, 3,000 ni ada square. 3,600 square. S dia dah potong dengan S kat bawah tu. Okay, divide with 1 hour square. 1 square. 1 square tak apalah sebab dia 1 juga kan. 1 square, hour square. Remember always refer to A, B square. Konsep dia A square, B square. Everybody inside the bracket mesti kena square. So that should be how you do the unit conversions. Okay, for those who having a problem, please, okay, balik ni cuti hujung minggu ni, tolong refresh balik how to do the unit conversions. Okay, alright. So this is another examples. Alright. Do you have any questions so far?
No, sir.
Before we go to the vectors. No. Okay, ada orang tanya sekejap . Sir, from Shami, sir, does we need to memorize all the unusual units such as mass and feet? Okay, normally, okay. For the unit and feet ni kebiasaannya at least tahulah 1 meter equals to how many feet. Simple. 1 inch equals to how many maybe one, yang simple one, the simple one. Okay, definitely they will give all the values. Okay, basically they will give all the values, but sometimes, okay, it is very advisable if you can memorize a little bit. Okay, a little bit of simple special unit such as miles and feet, for example. It's good questions. Okay, in fact, but always check with the appendix. Okay, when you're given the questions, it must come with the appendix, so it must come with the some sort like petunjuk. So always refer dengan benda tu. Okay, because sometimes there are some cases, okay, dia jenis suka menghafal, fine, but one fine day, not a very good day to him or to her, dia ingat tapi dia terlupa square. Benda-benda macam tu. That is something can happen in your life. Itu yang saya nak alertkan pada kamu. There is some cases macam saya cakap tadi, dia hafal tapi macam contoh dia, equation v square equals to u square plus 2as kan. Ada masa dia lagi dia terlupa ada square. Macam tu. Sebab dia suka hafal. Padahal dekat belakang soalan dia ada appendix. Dia tak nak guna. Tapi kalau appendix yang diberikan di belakang tu salah, cerita dia, aku hafal ni betul tapi kat belakang ni salah. Tak salah kalau kamu jawab. Maksudnya kalau kamu refer dengan kat belakang tu, this given to you, appendix that given to you, okay, tapi kamu pakai yang salah tu, tak salah jawapan kamu. Jawapan kamu akan dikira betul. Maksudnya kita whenever we do the marking, then we will accept your answers. Don't worry. The physics is not for punishment. Okay? Don't worry much in terms of that. Okay? Alright. So we have another two of maybe you can go to a little quick on the vectors. Okay? Because so this is the units of chapter 3. Okay. Why chapter 3? Is it because of chapter 2 we learn motion. Chapter 3 we have vectors. And these vectors should be the one that you should answer it, or we should learn it first before you do something else. Because vector is very important. Okay. And we need to solve the vectors. Alright. So let's go a little quick on the vectors. Okay. This is a scalar and vectors, right? A scalar quantity has only a half magnitude, okay? Magnitude. And a vector quantity has both magnitude and directions, okay? What is the examples of scalar quantity? Here we have length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, and power. And how about the vector quantities? Like this one, okay? Displacement, direction, velocity, acceleration, momentum, force, lift, drag, thrust, weight, whatsoever. But anything that have both magnitude and directions, okay? That is the vector quantity. Okay, a vector is represented by an arrow. Okay, when a vector quantity is handwritten, is it often represented with an arrow over the letter? Okay, so like this one. Okay, like this one. Normally, when you write down, okay, basically you just put arrow at the top of the letter, so that is considered to be vector A. If you just use A, this is not a vector. Please bear in mind. Okay, as a physicist, you need to know the difference. Right now, you'll be more analytical in terms of writing something. Okay, if you just use vector A is the 4i plus 3j. Wrong. Salah. Why? Because this one is just a normal A. So you need to put a vector A in terms of 4i plus 3j, for example. Because when you using your computer, for example, use a computer, you can bold this. Okay, you can bagi dia terang-terang macam ni. So ini tak apa, because vector can be write down as letter with the arrow. Okay, italic, maybe italic. Kalau italic lagi susah. Kalau tulisan orang tu semua di italic, ada kan tulisan orang macam ni kan? Macam ni. Macam mana? Takkan semua benda vektor. Okay. Ataupun bold. Takkan ke setiap kali nak buat vektor kena jenuh lah macam ni. So that is, itu saya nak bagi benda tu. Walaupun nampak macam pelik. Takkanlah ada orang buat macam tu. Tak, ada. Okay. Itu pentingnya kita be more analytical. When doing something right now, please, why? Always ask you, why? Kenapa Kenapa macam ni? Kenapa dulu kita ajar macam ni? Okay. Maybe dulu masa belajar vektor kat sekolah, benda ni tidak di-explain pun. Kan? Tapi right now, you need to know why. Okay, because we want to differentiate between vectors and magnitude. Vector have different, dia ada direction, dia ada arah dia. Okay. Okay, the equality of two vectors. The equality of two vectors. Hold on. Okay, two vectors are equal if they have the same magnitude and same directions. Movement of vectors in the diagram, any vectors can be moved parallel to itself without being affected. Okay, and adding vectors graphically. Okay, vectors can be solved. Okay, vectors perlu diselesaikan because vector ini simple je sebenarnya. Awak ambil satu garisan, you write down one length like this, and you calculate. Okay, how to calculate from point A to point B. Okay, you calculate, you measure, and let's say you give it 3 centimeters. Is it a vector quantity? Not yet, because it doesn't involve directions. So you can say that this length is actually 3 centimeters towards your right. Then it becomes vector. Simple. Vector is very simple. Whenever it involves the measurement with the directions, then we can call it as a vector. So when you have 2 or 3 more vectors, you need to solve it. You need to solve which one is the vectors, which one is the resultant vectors. Yes. So one of the way to solve the vectors is using graphically. Okay, grafik secara lukisan. And of course, cara lukisan ini dan satu lagi melalui calculations. So whenever the people ask you how to solve vectors, yes, you have two ways. Now, one is graphic, through graphic, lukisan. Another one is through calculations. And yang panjang-panjang yang dulu you buat tu, that is the calculations. Graphics, very simple. Kan? Bagi satu ni, bagi satu ni. Okay, tolong cari saya punya resultant vectors untuk vector A saya dengan vector B. Campur lah. Simple kan, campur. Senang saya cakap campur macam mana? Yes, that's vectors come. Okay. Kalau tengok B ni mungkin ada angle guys. So tengok dekat bawah, A plus B. Okay, vector A plus vector B. Tengok vector A at the end of vector A. So dalam kaedah graphical, we have two ways, which is tip to tail method. Okay. Tip to tail method, nama lain dia ataupun cara lain menggunakan lukisan ialah parallelogram. Parallelogram ni yang macam mana? Contoh dia, ni macam ni juga. Kalau A tadi, saya tunjukkan tip to tail. Tip to tail method in the graphical. So we redraw the A sampai sini. Dekat hujung A kita buat B. Dekat hujung A kita buat B. Dan kita garis daripada permulaan A ke penghujung B. So that is the real vectors. How do I know this one is a vector? Yes, it have a measurement. Dia ada panjang dia. Tapi selain tu dia ada apa? Dia ada angle dia. Angle inilah yang dinamakan direction. Simple So adding vectors graphically. Maknanya vektor yang problem yang susah-susah nak kira vektor ni sebenarnya boleh dimudahkan dengan cara lukisan. But please bear in mind, okay, through your drawing is not really accurate. Okay, the value, the final value for that when you do a graphical method is not really accurate because sometimes garisan tak sama panjang, okay, all sort of things. Okay, that's why datangnya calculations. Okay, so simple lah. Okay, this is how you do in graphical. Okay, A plus B, okay, then you get C. So A is 5 meters, and theta is 60 degree. Tengok macam mana dia buat. So 60 degrees above the x-axis. So it will tells you the details of the vectors. Nampak cara dia tulis? Dia gunakan italic. Tapi kita tak payah tulis italic, susah kan? Jadi kita buat A. Jadi kita tahu this is the A vector, vector A. How about vector B? 4 meters. Theta equals to 20 degree above the x-axis. So ingat x-axis walaupun duduk dekat Cartesian coordinate kat bawah ni, tak semestinya kita tak boleh bawa ke atas ni. Okay, so this is y, this is also x. This is one also 20 degree above the x-axis. Okay, So and then you calculated here tip to tail method daripada hujung awal A kepada hujung B, then you will get using a ruler and protractor. So you get 8.75 theta equals to 45. Okay, this is just a highlight to you because you already did that in your school. Okay, this one is also the examples. A plus B equals to B plus A. The same things. For the additions, vector A plus vector B then will be also equals to vector B plus vector A. But not for the subtraction. Subtraction is kind of different. Okay, so what is vectors in terms of negative? We always tell you negative. A tolak B. Is it actually because of this one? A tolak B ni bukan bermaksud A menolak vektor B, tetapi vektor A menambah vektor negatif B. Apa maksud vektor negatif B? Maksud dia, kalau vektor B ke arah atas tadi, direction dia, so vektor negatif B sama panjang, same length, but in the opposite way. So that is how that's how it mean by negative B. It's as simple as that lah. Semua orang takut dengan vektor kan. But benda ni simple je. A plus negative B. So now you know when you do the calculations, A plus dengan negative B, then you will get A minus B. Simple. Okay. Okay, so components of vector, we will proceed it next week, inshallah. Okay, but I want you to, when I give this slide in your Google Classroom, please, okay, maybe dapatkan slide tersebut, study balik untuk components of vector. All these things, okay. A cos theta, A sin theta, macam mana nak dapatkan dia, adakah kena hafal AX equals to A cos theta, AY equals to A sin theta, adakah selalunya bersama macam tu, okay. All this sort of thing, because when you have a good things macam mana ni, then every questions involve vectors, you can easily solve it. Okay, alright. So this is the adding vectors in terms of ni. You can read it first, then bila saya datang next week, kamu akan dapat senang untuk kamu explain. Okay, so I think I'll stop here. Any questions?
No, sir.
No, sir.
No, sir.
No, sir.
Kejap ya. Okay, sekejap ya. Saya ambil attendance sekejap. 49%, okay.
Sir.
Ya.
Ada seorang tu dia tak boleh masuk kelas sebab ambil vaksin hari ni.
Okay. Tak apa. Nanti kelas rep tolong WhatsApp saya nama budak tu Nama siapa-siapa tu. Boleh
Boleh.
Okay, thank you. Dua-dua kelas rep tolong PM saya, WhatsApp saya. This is my number. Okay, tu nombor saya. Okay. WhatsApp tu macam saya cakap lah, pada benda yang perlu lah. Okay, pada benda yang tak perlu, macam contoh dia hal-hal yang berkaitan dengan pelajaran lah. Kalau tanya apa-apa soalan pun ada masa-masa dia jugalah. Jangan expect saya terus reply jawapan sebab kalau saya terus reply tu terror lah tu. Tapi kalau saya boleh reply, maksud dia saya boleh saya ada masa lah. Tapi kalau saya tak reply pada masa tu, maybe saya akan reply kemudian. Alright, so please use it wisely. And for class rep, please PM saya. Ada yang dah PM dah, thank you very much. So that saya boleh whenever you can, kalau ada kelas cancel ke, nak buat gantian kelas ke, I can ask you directly. Okay, thank you class for your attentions. Right, so I'll see you next week during your lecture. Okay, lecture dulu. Okay, remember your lab session saya akan brief semasa minggu ketiga. So as for now tak ada lab apa-apa lagi. boleh bagi tahu dekat lecturer yang nak guna lab. Kalau nak guna masa physics lab tu, boleh. Tak ada masalah. Okay, thank you kelas. Assalamualaikum warahmatullahi wabarakatuh.
Salam je. Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.